the border of Europe and Asia, in Turkey, lies one of the most majestic monuments on the planet, the Hagia Sophia of Istanbul. This monumental structure was built more than 1,500 years ago as a basilica, transformed into a mosque, and then a museum, and recently converted back into a mosque. Its 6th century dome soars more than 55 meters, the equivalent of a 17-story building.
There are 40 openings that allow the interior of the dome to be illuminated. It's a fabulous innovation.
It had been a challenge for architects for the coming millennia. How does it stand?
Today, researchers studying the 7,540 square meter monument rely on the latest technology.
Wow, it looks so impressive. Actually, from our level, it looks much different.
By scanning from the aerial scale to the satellite scale and the molecular scale, specialists can now unravel the greatest mysteries of this UNESCO World Heritage Site. How did builders piece together and transform this structure over the centuries? What is the secret to keeping its gigantic dome standing?
This is a higher vault than any of the Gothic cathedrals that were built centuries later. There is no precedent for it.
Positioned on one of the most active seismic faults in the world, the Hagia Sophia has resisted earthquakes since the 6th century. What architectural mysteries can science reveal to explain this impressive resistance?
So what we learn is how the structure behaves differently at different locations.
And what incredible discoveries have recently been unearthed from the depths of this iconic monument?
There is Hagia Sophia Subterranean. This is another world. This is another marvel of Hagia Sophia.
We visited places no one's ever seen, and we made new discoveries.
History, science, engineering, exposed as never before, Istanbul's Hagia Sophia finally reveals itself on every scale. On the shores of the Bosphorus, the Hagia Sophia's iconic silhouette stands out on the Istanbul skyline. A massive building with a gigantic dome and 4 towering minarets. Builders carried out a series of modifications over its 1,500 years of existence, leaving a complex structure combining centuries of engineering ingenuity that still fascinates historians today.
The building has been there since 6th century, and it had a very, very long afterlife, so it's like a patchwork.
Today, archaeologists are using new technology to solve the greatest mystery of the Hagia Sophia. They want to unravel the sequence of building works that form the building. Bilge Ağar is a professor at the Department of Architecture at Istanbul Technical University. She thinks that the key to understanding the structure of the current building is to investigate its original construction.
Behind me is the 6th century Hagia Sophia, but the 6th century Hagia Sophia is the 3rd building with the same name that is standing here.
The Hagia Sophia today is in fact the 3rd building of this name to stand here. The first was completely destroyed by fire. The second was built in the 5th century, and traces of it still remain today.
Behind me, we see the original ground level of the 5th century Hagia Sophia. We see some friezes back there with some decoration on it, and we have some remains of its entrance portico. The whole building occupied about the same amount of ground space as Sophia today.
3D modeling techniques make it possible to visualize the 5th century basilica that preceded the Hagia Sophia we see today. Builders made an immense 60-meter wide structure in a rectangular form, fitted a wooden roof, and an entrance portico supported by a series of monumental columns. The structure suffered the same fate as the first that stood here.
Hagia Sophia of the 5th century was burnt. So Justinianus immediately started the project of a new cathedral.
After the second Hagia Sophia burned to the ground, 6th century Emperor Justinian, ruler of the Byzantine Empire, decided to build a third version of the monument. The Hagia Sophia that he started would be transformed and upgraded by generations of builders over the next millennium, leaving a gigantic puzzle that can only be deciphered using the latest technology. Bilge usually studies the building from the ground, but today she's working with drone operators to investigate the building from the air for the very first time.
We will take some shots, wide angles, and some close-ups. We are very ready to flight.
By flying over the Hagia Sophia, almost 100 meters above the ground, the aerial views change the scale of her observation.
Wow, it looks so impressive. Actually, from our level, it looks much different. It's very important to grasp the buildings in a three-dimensional scale. The drone, it's actually like a 3D model. It's a complete different thing, and the three-dimensional figure would give us much more opportunity to understand and express what we have to tell about the building.
Today, it's difficult to recognize the design chosen by the monument's original builders. But the drone views allow Bilge to spot the original plan of the third Hagia Sophia.
Well, basically, when we look at the plan, it's a basilica. I mean, it's closer to a square, which is typical for a Constantinopolitan basilica.
It's 71 by 77 meters. Then the dome is placed on this square through a series of extremely sophisticated construction elements.
Well, the main challenge is certainly to put the round plan of a dome over the rectilinear plan of a basilica.
We should look at this building as an experiment, and a building in a colossal scale, trying something that has not been tried before.
3D modeling exposes the unprecedented architectural innovation of the Hagia Sophia. This is the first time that engineers building a basilica of more than 5,000 square meters would install a monumental dome measuring 32 meters in diameter. And they extended it by building 2 semi-domes on each side. Finally, they added 4 massive buttresses to each side of the 6th century building. But today, the Hagia Sophia's layout appears much more complex. That's because generations of builders would go on to add new structures to the original building. These modifications are easily spotted from the air by drone.
Could we go to the eastern parts? We will see the later buttresses. Attached to the narthex, we see a series of buttresses. They could be added as a repair activity during the Latin occupation, or maybe in the restoration period afterwards.
These are flying buttresses used in sequence as they would be in French Gothic construction. So it's the Latins who are in control of the city are importing a structural system that is developed in France and using this as a way of stabilizing the older cathedral of Hagia Sophia.
Bilge uses the drone to investigate a final addition to the structure. A feature ordered built in the 15th century by Sultan Mehmed II of the Ottoman Empire, some 1,000 years after the monument's initial construction.
When Constantinople fell to the Turks, Mehmed II transformed Hagia Sophia into a mosque. So it needed a tower for the call for prayer. So the first minaret was added during his time.
And then the minaret was expanded to 4 minarets. In fact, You don't need 4 minarets. These are functionally superfluous. But visually, the idea of the dome framed by the minarets becomes a very prominent symbol.
Architecturally, it was not surpassed for many centuries to come. The influence this building had on world architecture is immeasurable.
After a millennium of transformation, this innovative building became an architectural model for the mosques of the new Ottoman Empire from the 15th century.
You know, when I first arrived in Istanbul, I could see the silhouette of Hagia Sophia, and my heart stood still, and I thought, I have arrived. And then the bus went around another corner, and there was another Hagia Sophia. And then it ran around another corner, and there was another Hagia Sophia. And finally, I realized it's that all of the mosques in the city look like it.
While the monument's exterior appearance became an iconic mosque design, inside the building, visitors are impressed by the extraordinary volumes of the structure, and especially its gigantic dome. A true architectural feat, it is known as one of the greatest masterpieces of antiquity. With a diameter of over 30 meters and a height of over 55 meters, it has 40 windows that bathe the whole interior in light.
When we look at 6th century attestors of the building, their descriptions also say the same thing. Procopius, for example, says the dome is like it is suspended from heaven with a golden chain. The effect of these windows making a break between the dome and its all structural elements. So it feels like the dome is just flying in mid-air.
All that airy side of the dome, all those side windows, they were full of light. Visitors were surprised. They wondered how it would hold.
How did builders manage to construct this colossal structure, which seems to float in the air, without modern techniques and tools? The answers lie in understanding the origin of the Hagia Sophia. When the Emperor Justinian demanded it built in the 6th century, he ordered his architects to surpass a building he considered the most impressive in the world. A monument located almost 2,000 kilometers away in the heart of the ancient city of Rome.
The first idea was to compete the Pantheon in Rome with its great dome. A building that has set itself up to be admired, but also to be imitated. And with Hagia Sophia, it's not so much imitation, but doing something that goes beyond the Pantheon.
The Pantheon is a circular dome, built without going into detail, in a kind of very solid concrete.
The base of the dome is continuously carried by masonry walls. Here we have a skeletal system. The dome is carried by 4 very large arches, which are supported by 4 very large piers. So the architecture of the place is actually a colossal canopy.
3D modeling exposes the challenge that builders faced. They would build a dome on top of a square structure formed by 4 pillars, linked together by 4 Roman arches more than 30 meters high. But the innovation didn't stop there. To surpass the Pantheon, Emperor Justinian bets everything on the gigantic dome. In contrast to the Roman dome, which is built in the form of a sphere, the emperor wanted to build a lower dome to symbolize a celestial vault, and to do something never attempted before, fit it with 40 windows.
And this is new. The first innovation is to build a relatively low dome. There, the light of God must be brought into the church. And so all this is a huge innovation.
What this means in terms of the design is that although it appears transcendental, airy, weightless, and so on. It is in fact a very heavy building.
The low dome collapsed only a few years later after its construction and was immediately rebuilt in its present form. But how did engineers allow this dome, weighing thousands of tons, to rest on only 4 pillars? 3D technology exposes the hidden secret of its construction. The dome is built with 40 ribs that form a stone framework.
That is not a flat surface, but the interior of the dome is ribbed. There are ribs, like the ribs in an umbrella, that will strengthen the dome.
40 ribs are used to hold the dome. And then, between the ribs, there is brick filling, which needs to be as light as possible.
3D modeling reveals the material hidden under the decoration of the dome. A very special type of lightweight brick. Examining the brick on a microscopic scale reveals that builders made them from a mixture of earth and tufa, a very light material. At the time, these bricks were so light that engineers claimed that 12 of them weighed no more than an ordinary brick.
Once we've done that, we have our rib dome. We have to put the whole thing on what we call a drum to distribute the loads of the dome because we can't leave the 40 ribs up in the air like that. What will allow something very innovative, once again, is to pierce this drum with 40 openings that will allow us to illuminate the inside of the dome, the entrados, as they say.
This is how the builders were able to allow a ring of 40 windows around the base of the dome. This would be impossible at the Pantheon.
So there again, great innovation. We light up the sky, extraordinary.
The 40 windows also made the structure considerably lighter. But there was another problem that would challenge builders. They needed to safely distribute the weight of the circular dome onto 4 pillars, forming a square.
When we cover a square space with a dome, which has a round base, we need some transition elements to make the change from the square to the circle. So the pendantives are basically actually doing that. So as we see behind me, they are these spherical triangles. They are part of the structural system. Between the arches and the base of the dome, they are covering the empty area.
The solution was to fit triangular devices called pendentives that work like a buttress arch. They redirect the weight of the dome and concentrate it at the 4 corners over the pillars.
So there lies the wonderful innovation of making this connection between circle and square at an extraordinarily large size, to put it simply.
But to complete this innovative building, builders needed to solve one last structural problem.
With the weight of the dome, there's a tendency that the pillars and the arches tend to open up.
To withstand outward forces, builders added 2 huge half-dome structures to the east and west. Then they built 4 massive exterior pillars to the north and south. In just a few years, the builders of the Hagia Sophia succeeded in their mission of surpassing Rome's Pantheon and building an iconic new monument.
It had been a challenge for architects for the coming millennia, and it hasn't been achieved for a very long time afterwards.
This is a higher vault than any of the Gothic cathedrals that were built centuries later. So it's a dome that is not surpassed until the 16th century.
Architects designing and building the massive dome of the Hagia Sophia had to learn from their mistakes. Over centuries, they added reinforcements to consolidate the building, features preserved at this UNESCO World Heritage Site to this day. Incredibly, this huge monument has withstood numerous and severe earthquakes. One of the most dangerous struck Turkey in August 1999. The earthquake had a magnitude of 7.4 on the Richter scale and devastated the region of Izmit near Istanbul. thousands of people lost their lives and hundreds of buildings were destroyed.
I was there in 1989. The house next door to me collapsed. It was out on the street in my underwear at 3 o'clock in the morning, not knowing what to do. And the next morning, my colleagues who were working on the restoration of Hagia Sophia were back on the scaffolding at work. There was no damage to the building at all.
Why is the area so prone to earthquakes? Examining the region on a satellite scale exposes the answer. Istanbul is situated close to the North Anatolian Fault, one of the most active faults in the world. It's the border between the Anatolian and Eurasian geological plates. As these plates slide against each other, moving about 2 centimeters every year, pressure builds and is released during earthquakes. But despite this threat, the Hagia Sophia has remained standing until today. Clues to explain how this is possible can be found by examining something invisible to the naked eye, the stratigraphy of the soil. The Hagia Sophia is built on top of an anticline, a fold in the Earth's crust created by the movement of tectonic plates formed more than 400 million years ago. Examining the rock at a microscopic scale exposes that it's a stone known as compressed schist, a particularly strong material. But this alone doesn't explain how the monument stays standing. Eser Çakti is the director of the Seismic Laboratory of Boğaziçi University in Istanbul. She has been commissioned by the authorities to assess the ancient and future capacity of the Hagia Sophia to resist earthquakes. Her team has placed the monument under high surveillance using state-of-the-art technology. She wants to understand the building's movement and its reaction to tremors.
The technology that we use in the structure is to monitor earthquakes or earthquake vibrations on Hagia Sophia, on the structure. We put altogether 9 sensors at various locations.
Of the 9 seismic sensors placed in the Hagia Sophia, 4 are placed at the top of the dome, 4 at the arch levels, and 1 is located on the ground. The sensors operate 24 hours a day and continuously record and transmit the structure's slightest vibrations to the Seismic Study Center.
Last week we had a 4.2 magnitude earthquake close to the city of Istanbul, and this was actually recorded by our stations and mainly by the recording system in Hagia Sophia. Therefore, this earthquake was actually felt by Hagia Sophia.
The researchers use daily information collected by the sensors to carry out 3D simulations that amplify the building's deformations and expose the Hagia Sophia's weak spots.
So what we learn is how the structure behaves differently at different locations. Some points, they vibrate more as compared to the other points, particularly the eastern and western arches. Also some of the piers, main piers. So for those locations, we pay more attention in our analysis and look at them in more detail.
In recent years, the seismic research team has been using a new technology to monitor the arches and pillars more closely and assess whether significant deformation is taking place. Laser scanning. The technology allows them to monitor large surfaces and discover details invisible to the naked eye.
The laser scanner allows us to easily scan with high resolution a very large area up to 120 meters wide.
This is invaluable information because, the size of the structure, it's huge, it's colossal. However, deformations in the order of centimeters may mean a lot. But from the ground level, you might not be able to sense those deformations in the order of centimeters, while the sensors can.
By taking millions of measurement points every second, the researchers can create a detailed 3D model of the building. Every year they create a new model, allowing them to compare point by point the slightest micro movements in the superstructure.
We have compared the images or the information, and according to our analysis and comparison of our results, structure has not moved recently.
Today, the Hagia Sophia seems unshakable, but this wasn't always the case.
A few years after its construction, the dome collapsed.
Engineers building the first dome of the 6th century Hagia Sophia used a different design to the one we see today.
The dome was built in a relatively low-profile manner. The Pantheon is completely inscribed in a sphere. And so this lowering has also weakened the dome.
With its peculiar geometric shape, the forces exerted by the original dome were directed to the sides, making the structure particularly unstable in the event of an earthquake.
With the collapse of the first dome, the architect of the second dome went safe rather than daring in his design, so that the geometry of the dome as it was rebuilt is different from the original geometry of the dome.
When it was rebuilt a few years later, it was reassembled.
5 years after its collapse, architects built a new dome, 6.25 meters taller, reaching its current height of 55 meters. The new dome might be higher and heavier, but it's also much stronger.
It was built higher, no doubt it was heavier, but the form was more stable. That is rather than pushing outward, the thrusts of the vault are pushing more downward because of the hemispherical form of the dome.
The reconstruction of the dome in this new form was crucial to the final earthquake-resistant shape of the Hagia Sophia today. Now, new technology like 3D laser scanning lets researchers peer back in time and identify the challenges that the builders faced.
What you see is the damages or the reconstructed parts of the main dome. On base level, you can easily see where the two parts of the dome come together. One part is the part that was destroyed during the earthquake, collapsed and reconstructed, and then the other one, the adjacent part, is the one that was original, that never collapsed, in fact, according to our knowledge today.
After its first reconstruction, the dome partially collapsed twice more. The damage allowed builders to analyze and compensate for the final weaknesses of the structure. 3D modeling techniques expose innovative reinforcement that the original engineers dreamed up. In addition to the half-domes that held the main dome in place, they added huge pillars to the north and south. In the 14th century, a new type of reinforcement was added to the east, a flying buttress, followed by a series of further work in the 16th century. The constant adaptation and additions that builders carried out over the centuries are the secret to the Hagia Sophia's strength today.
There is no doubt that Hagia Sophia, at the time it was constructed, of course, the best architects, constructors, masons of the period was used. There is no doubt about this. And then it has been very well kept over the centuries. That's why it is still standing.
But the engineering of the building is not the only explanation for the incredible earthquake resistance of this monument. Examining Hagia Sophia on a macroscopic scale reveals that builders chose brick and mortar to construct its walls.
They were fairly thick bricks, about 50 centimeters long and about 30 centimeters wide. And it must have been 4 to 5 centimeters thick. But the thickness of the mortar was comparable.
This is a key feature of the building. Engineers chose to set bricks into layers of mortar of similar thickness to the bricks they held. The ancient technique has been studied by Eftal Kiraz, Deputy Director of the Istanbul Conservation Laboratory. His team studied the building's mortar on a microscopic scale in order to recreate the original builder's techniques and replicate it during restoration work. His team were able to figure out the exact composition of the material.
This material is made from limestone, is made from brick powder, and also is made from stone powder.
Investigating further on the molecular scale, the team discovered that the brick powder was made from a rock of volcanic origin called pozzolana. This ingredient gives the mortar special properties.
It's a softer and stronger material when compared to modern cement, for example. It's not that it's like rubber, but it's very flexible and very resistant to earthquakes.
The elastic property of this mortar allows the building's walls to deform instead of crack, absorbing shock waves and helping the monument resist earthquakes. But according to experts, the mortar of the Hagia Sophia has another important property.
Mortar will develop micro cracks in it and will reset after the cracks will readhere. There's something in the chemical property that means this will be a particularly stable form once it's set to its ultimate hardness, but it can adjust.
Thanks to their careful choice of materials and upgrades to the Hagia Sophia structure over centuries, generations of engineers succeeded in building an iconic monument capable of resisting frequent earthquakes.
Whether it will stand the next big one, only time will tell. What we know from history, though, is it never collapsed totally. It has definitely a remarkable earthquake resistance, that's for sure.
Seismic engineers can't predict with certainty whether the monument will withstand the next big one, so the Hagia Sophia remains under close surveillance. The original 6th century monument was built in the space of just 6 years, an astonishing feat that impresses specialists even today.
This is under 6 years to build a building that is larger than any of the great Gothic cathedrals in France. You could put Notre Dame inside Hagia Sophia. I think only the towers would stick out. This is absolutely remarkable.
This building has survived to this day, with its beautiful mosaics, decoration, pillars, pillar bases, all of which give a unique beauty to St. Sophia.
Today, the Hagia Sophia is a magnet for visitors to Istanbul who marvel at its incredible engineering and scale. But the decoration of the interior is equally as impressive. And that's partly because of the material choices that builders made. Olcay Aydemir is responsible for the restoration of the Hagia Sophia. According to her, the unique beauty of this monument can be explained by the use of precious decorative materials.
This marble door is truly a masterpiece of its time. This monument is unique with its materials, structure, and ornamental composition. The base is made of bricks, but the whole structure is covered with marble stone, and partially with different types of marble.
Examining the Hagia Sophia on a macroscopic scale exposes a palette of marble, each one more precious than the next. White, green, and even red marble, alongside an incredible display of glass mosaics. But where did the Hagia Sophia's engineers source these materials? Sometimes it takes centuries and new scientific approaches to reveal the secrets of the builders. Nadine Shabil is studying the origin of mosaics at the Hagia Sophia. By carrying out chemical analysis of the glass, she has revealed the geographical origin of these materials.
90% or over 90% of the glass does come from Egypt, and the chemical composition shows me that without any doubt. This in itself is not so surprising because glass was produced in Egypt, we know that, and Justinian gathered material from all over the empire.
Examining this part of the world on a satellite scale helps visualize the origin of material used by builders. Black stone came from the Bosphorus, green marble from Greece, precious stones from Syria, and glass from Egypt. Builders chose materials from all over the Byzantine Empire to decorate its greatest monument. But the choice of materials offers more than just decoration at the Hagia Sophia. Inside, the light seems to diffuse through its walls.
6th century descriptions emphasize exactly this aspect. You have this just vast space that is suffused with light, and this is very impressive.
The impression given was that the light came from inside, not outside. And so to have managed to create this atmosphere was something completely new, something totally new.
The Hagia Sophia's 4 monumental arches allow the structure to be opened up with windows on all floors. But it's the choice of special marble, visible on a macroscopic scale, that contributes to its unique appearance.
Marmara marble is a local stone from Turkey. This marble, in the sunlight at the end of the day, is slightly transparent.
The marble is translucent and has a high refractive index due to calcite crystals, the main component of the stone. So light penetrates the surface of the stone before being reflected, giving the material a unique glow.
Here we see the link between light and stone. Everything that has been created here was not made by chance.
The expertise of the architects, that in itself, to me, is just very impressive. So the lower levels of the building are covered in marble decorations. The upper levels of the building are covered in mosaics. Vast amount of the mosaics are actually gold leaf, and gold leaf mosaic tessera are highly reflective. So the tessera are actually angled so to catch the light that comes in. So they try to make the most out of the natural and artificial light in interaction with the surfaces.
Builders fitted an astonishing 16,000 square meters of gold decorations in the 6th century, making the interior of the monument shine. Originally, these lavish Byzantine embellishments almost completely covered the Hagia Sophia. Then, in the 15th century, the Ottomans transformed the building into a mosque and chose not to destroy the mosaics, but to cover them over with mortar. So what Byzantine decorations remain hidden today? What treasures of the Hagia Sophia are invisible to the naked eye? The Great Dome, a masterpiece of Ottoman art, has remained unchanged since the 15th century. But the majestic calligraphy conceals another treasure, created 6 centuries earlier.
We know that by the 9th century, there was an image of Christ where that calligraphy was located.
According to some researchers, a huge artwork is still hidden under the calligraphy of the dome, a gigantic mosaic representing Jesus Christ. Other structures of the Hagia Sophia, invisible to the naked eye, have spawned many legends over the centuries.
There's a lot of interest in what is under Hagia Sophia today. There are curious accounts from people who visited historically who said, oh, there's a great cistern under Hagia Sophia, and that there is this network of tunnels underground. Your first thought is, aha, mystery. This is exciting. Where does it go to?
From 14th century, the pilgrims, ambassadors, travelers, they talk about this cistern. They say that almost 3,000 boats could sail in it until the sea.
Could there be truth in this legend that has been passed down for centuries by travelers? What mysteries lie deep beneath the Hagia Sophia? Clues to this enigma lie just a few hundred meters away at the Theodosius cistern, an astonishing underground reservoir built in the 5th century at the same time as the second Hagia Sophia.
So this is a Byzantine cistern, basically. It is 40,000 cubic meters of water capacity.
Çiğdem Uzkan is an archaeologist and professor from the Department of Human and Social Sciences at Istanbul Technical University. She believes that the legend of the Hagia Sophia's subterranean secret stems from a feature of the city during the Byzantine period.
We know there are 209 cisterns in Istanbul. Some of them are not existing, of course, but we know the existence of them. But there should be much more than this.
Examining satellite imagery and 3D reconstructions exposes what is hidden underneath Istanbul. Hundreds of underground tanks were built during the time that the city was known as Constantinople. These reservoirs were connected to a vast hydraulic network more than 500 kilometers long that kept the city supplied with water.
It's an amazing waterwork, which shows us all the tradition coming from the Roman technology.
This ancient water network could have inspired the legend of the giant cistern hidden under the Hagia Sophia. To solve the mystery once and for all, Professor Aygun assembled a team to investigate the subterranean world of the Hagia Sophia. She wanted to explore the depths of the superstructure. She obtained special permission to carry out one of the most incredible excavation campaigns that the monument has ever seen: the exploration of passages deep underneath the Hagia Sophia.
Of course, we were extremely excited and curious because it was a chance for us to discover mostly about those structures which has not been studied before.
We came here like adventurers, with a view to discovering. We went to places no one has ever been able to see, and we were able to make new discoveries.
For 9 days, the research team explored the depths by every possible means. Caving specialists and divers joined forces to discover 8 previously unknown wells. Professor Aygun's multidisciplinary team recorded their exploration into these unmapped areas.
We are in the well of Hagia Sophia in the nave. It's full of water. This well, most probably, is the source of the legends, beginning from 14th century. The pilgrims, travelers, ambassadors all mention about it because it's plenty of water. It's always full, 10 meters of water all the time. So they thought, okay, there must be a big cistern there because there is always water in it. The water is coming from somewhere. So they thought the source is much more bigger.
The water source seemed limitless in the eyes of medieval visitors. But where does it come from?
Okay, when I stop pulling, you can read the measurements.
The team carried out chemical analysis of water and rock to make another discovery. The water in this well does not come from a cistern or from rain, but from underground water sources, a natural resource located under the Hagia Sophia. Revelations about what lies underneath this monumental building didn't stop there.
I began from the wells and I found a world underneath. We have found almost 1 kilometer of water channels there. Some of them are drainage channels. They are mostly underneath because they are draining the excess water from Hagia Sophia. And under the western courtyard, there are the main supply lines. And that makes Hagia Sophia a part of the greater, longer supply line of the city.
According to initial findings, the Hagia Sophia does have a hidden hydraulic network, but not a large cistern connected to the sea by canals. To investigate inaccessible areas of the underground network, the team turned to new technology, an ROV, or remotely operated vehicle. They used the ROV to access areas underground, including underwater, that are too narrow or too dangerous for humans. Thanks to this specially adapted machine, Professor Aygun's team was able to explore galleries leading to an incredible discovery: remains of the ancient Hagia Sophia.
Under the Ezonar text, there's a vaulted structure supported by 23 piers. It is most probably prior than Justinianic Hagia Sophia.
Examining aerial images reveals the location of these hidden remains under the Hagia Sophia, a vaulted structure built long before the current monument. Evidence that when the original and second Hagia Sophia basilicas were built and burned down in the 5th and 6th centuries, engineers saved time by building directly on top of the old structures.
We can create more ideas, more theories about the prior Hagia Sophia. So this is also very interesting for the unknown history of Hagia Sophia.
Now the team has discovered an even more mysterious structure to the south of the building. By taking precise measurements in the field, they've been able to model the enigmatic room in 3 dimensions. They believe it was originally a tomb called a hypogeum.
We have found that it was a funeral hall, not only one hall, 3 halls together connected to each other. And most probably it's prior to the first Hagia Sophia. Hypogeum is the most enigmatic maybe because its walls are broken on the east and on the west, and 2 water channels are added into it. So it is converted into a water structure. And why and when did they do this? It's in the Byzantine era again they did it. But why they have neglected this tomb and converted it? This is the question that we are answering now.
Professor Aygun's team have discovered treasures from the Hagia Sophia's past. 1,000-year-old structures lost deep underground.
There is a Hagia Sophia beneath the Hagia Sophia, so there is Hagia Sophia Subterranean. This is another world. This is another marvel of Hagia Sophia.
Now the team of archaeologists are waiting for new permission to continue their excavations. They want to further explore other discoveries they made, such as a submerged hall located nearby under the Topkapi Palace.
It's very beautiful here. You feel like you're entering a cloud, and the structures suddenly appear.
It's a tantalizing glimpse of the exceptional Byzantine remains that have yet to be discovered around and inside the Hagia Sophia. Decade after decade, archaeologists, aided by the latest technology, have unearthed many of the secrets of the Hagia Sophia. A monumental puzzle modified over the centuries, a robust structure designed to resist earthquakes, built using incredible engineering innovations. These are all characteristics that make this 1,000-year-old monument a world heritage of humanity, whose legacy must be preserved.
It is undoubtedly one of the most important architectural pieces, certainly of the first millennium, but probably in history more generally.
It's a cradle in the history of architecture and history of human beings. You have to see it and you have to experience it.